Welcome to this session of Shadow the Scientist. My name is Jamaica Marshall, and I'm very pleased to serve as the Shadow the Scientist coordinator. Shadow the Scientist is an initiative housed under the Creating Equity in STEAM umbrella of programs offered by a team at the University of California, Santa Cruz. The Las Cumbres Observatory is a worldwide network of robotic telescopes run by a nonprofit private operating foundation. The telescopes include the Haleakala Observatory on Maui, the McDonald Observatory in Texas, Cerro Tololo Observatory in Chile, the Tide Observatory in the Canary Islands, the South African Astronomical Observatory in South Africa, the WISE Observatory in Israel, and the Sidon Spring Observatory in Australia. Now, utilizing telescopes that are spread around the world greatly increases the opportunities to observe all astronomical events. The light from celestial objects can be sampled with greater frequency and for longer duration when observations are passed from one telescope to the next. Now, to get us started, let's go ahead and join our guide on this cosmic journey, JD Armstrong. JD, welcome.
Welcome, man. Thank you. It's wonderful to be here. It looks like we're filling up. We got a good crew here. Thank you all for joining us. I know we were going to talk about asteroids, but I thought it'd be fun to see if we can't put an observation onto the Las Cumbres Observatory first thing, and see if we can't get images back before we're done.
That would be fantastic. That would be amazing. And I believe you have several choices for us, JD, right?
I've got a couple of choices. So, yeah, we were talking, okay, being honest, breaking the fourth wall here. We were talking about this before, and Jamaica, you really like globular clusters like 47 Toucan, right?
Yes, I love globular clusters, JD.
Okay, so so we'll put two choices up. That's number one is 47 Toucan, and we'll see what we get. It will look different than that. We're going to hide this because that's probably a Hubble image or something like that, and we'll make.
Are you sharing your screen, JD?
Oh no, I'm not. Am I? That would help.
Yes, please.
All right, that better?
Yes. There we go.
Sorry about that, everyone. So this is 47 Toucan. This is a globular cluster, and it's the second brightest globular cluster in the night sky. And Jamaica likes globular clusters, so that's why that's on the list. And we are also thinking about, there's a comet that maybe we could take a look at. So I'm going to go to Earth. I think I'm saying that right.
Yes, I think this is comet 2022 E2.
Yeah, and this is it. Okay.
This is a beautiful comet.
Yeah, it might very well be. So 2023 C2. Is that right?
Oh, no. We were going to do 2022 E2.
Echo 2. Yeah, that looks
Echo
better.
2.
The right ascension and declination make it a little easier. So what we are going to do now is let's go ahead and take a vote whether if you'd like to try to get the comet or the globular cluster, Omega said.
Yes. So first, since we have the comet on screen, if you could raise your virtual hands to show if you want us to put in a request to observe, get observations of this comet 2022 Echo 2. You can also um, drop it in the chat if you want the comment. So we're looking for your responses right now in the chat. Okay. I see one hand. Yeah, the detail. Annalise. Yes, thank you. Let's see. Who else? I'm scrolling through. I see some more hands. Hinal. Excellent. Let's see. Anyone else for the comment? I love comments. Okay, Amalika, amazing, wonderful. And I do apologize if I mispronounce your name. Please feel free to submit a phonetic correction uh, in the chat if I mispronounce it. So thank you so much, and I do apologize. Yes, okay, all right.
All right.
So we got 5, 6, 7. Yes. Okay. So Kushi also. All right. So let's go to the globular cluster, which is my favorite. I love globular clusters. So let's see that image of the globular cluster again. This is one in the southern hemisphere, correct, JD?
Yes, it's in the southern hemisphere. The declination is negative
Negative,
72 degrees. So
negative
this is,
72.
you'd have to be at negative 72 degrees latitude for this to pass directly overhead.
There we
So
go.
you'd have to be pretty
Okay,
far south. It's, yeah,
that's actually very far south.
that's right.
Um, Okay, so if you want JD to submit an observation for this beautiful globular clusters are groups of very old stars that are tightly bound together by gravity, and they typically orbit kind of above and below the halo or the bulge of galaxies, right, JD?
Yeah, they typically orbit the galaxy, and what we think they are is remnants of galaxies that have been cannibalized. So if you imagine a disk galaxy with a bulge in the middle, it's the bulge in the middle, and the rest of the galaxy has been stripped away and
Yes.
become part of the Milky Way.
So while I'm waiting for you to, if you want us to submit observations for this globular cluster, this is instead of the comet, go ahead and raise your virtual hand, give us a virtual thumbs up, or you can drop it in the chat and put globular cluster. Um, while we're getting a count of these, JD, there is a globular cluster that some people may be aware of. That's the brightest, because this one is the 47 Tucan is the
Oh
second
yeah.
brightest globular cluster, but the first brightest is actually Omega Centauri, which is one of my favorite stargazing objects. I love showing people Omega Centauri. I have many images of it myself. And this is very, very dense with millions of stars, right?
Yeah, I think it's I recommend reading the article here, but I believe it's
Oh, definitely.
it's over 1 million stars. Oh, estimated to contain approximately 10 million stars. That's a lot bigger
Okay,
than I thought it was.
10,
Wow.
10.
Yeah.
That's really, really huge. So let me drop a link to this Wikipedia page in the chat about Mega Centauri. And yes, we're getting lots of thumbs up for, I'm sorry, for the globular cluster 47 Tucane. JD, I don't know. How do we choose between the comet and the globular cluster?
How many votes did we get for each one?
I feel like we got 8 for the globular cluster. I'm sorry, yeah, for the globular cluster, and I saw 6 for the comet. That's pretty close,
I know
though.
you got up to at least 7 on the count. I don't know.
Okay,
I'm thinking that there's a little bit of
there's another
bias
one.
in this election, so
What?
maybe we should just do both of them.
Okay, we can't go wrong doing both. Okay,
All right,
hoping
is
that will
everyone?
satisfy
How many
everyone.
people want to do both?
Can I raise 2 hands?
There you go. Yes, go ahead and raise 2 hands. Okay, let's just go ahead and do both since uh And 47 Toucan it's really kind of interesting. This is one of the oldest globular clusters that is known. It's like 13 billion years old, really very old cluster of stars. And I've got to agree, this is one of my favorites of all time.
It's stunning.
Yeah.
It is stunning.
I'm just going to go 30 seconds. Hopefully that'll be all right. We'll go ahead and do a color image. So we need our eyes see our eyes have cells that detect all light, so black and white, and then red, green, and blue. So there are three types of color receptor cells. Some detect red, some detect green, some detect blue. And so we'll need to take an image in red, green, and blue and then combine it to get a color image. And so this is the Las Cumbres observing portal. We're going to put the name of the object in here as 47 Toucan, and then STS, I think lowercase middle t in the middle there,
That's
like
right.
that.
Thank you. Perfect.
Okay, good. Just to remind me, oh, this is for these guys, for this group of people, and let's see here. So instrument configuration. Um, First of all, we just need to give it an account. Q scheduled. Most of these factors are just leave them alone. They're usually the right setting, unless you're doing something really fancy. We want to get an image. We don't want a spectrum. We want an image. We'll use these small telescopes because these will get on sky really quick. And so we might get this before we're done. We just want to take one image for 30 seconds in the blue. I'm going to go for the full frame readout, see how much, go as big an area of the sky as we can. And then the object is 47 Toucan, and tracking sidereal. There's an option to track on asteroids, which is really nifty. And so it looks up. So if I paste this in here, it says, oh, I found this object. Here's the right ascension declination. Now, right ascension, it's like east-west. It's a measurement of east-west in the sky. Imagine that the sky above us is like this big, huge sphere or globe around the Earth. And to measure east-west, we use right ascension. But instead of degrees, we use hours because because it used to be easier for some of the math to use hours, minutes, and seconds. So this is like hours, minutes, seconds, and then being modern, that gets converted into degrees. And then the declination is like how many degrees north or south of the celestial equator, so the middle point of the sky. And this is pretty far south, 72 degrees south. That's getting pretty close to the the south pole of the sky. And so there we've got the visibility. This is showing when it's visible. And let's see, oh, we need to go back and we need to make a green and a blue frame. So Bessel B is our blue filter. Bessel V, as in Victor, is our green filter. And then we want to do a red filter, which is Sloan Digital Sky Survey red. Okay. Oh, good. Yes, that's nice. I just saw what you put in the chat. Thank you.
Oh yeah, absolutely.
Yes. Okay. And I'll leave the visibility like this. Hopefully, if it can, it will pick this observation up while we're online. This is a 3-minute observation, 4 minutes. Yeah, we've got some time to go ahead and do both of these.
Let's
So
do it.
yeah. So the next one, we were going to go with Comet 2022 Echo 2. All right. And the reason, if you want to go here, you can take a look at it. This shows the bright comets that are up right now and possibly visible. Starting with this one, I hope some of you got to see this comet. You can see it with the unaided eye. We actually had a star party up at the Institute for Astronomy and had nearly 300 people here, if you can believe. It was really crowded, but everyone's, we all got to look at the comet. It was really fun.
Wow.
And so this list has the brightest ones first, but here's the problem. The right ascension of this object is 18 hours, 43 minutes. The right ascension of the sun right now so notice I Google these things. Okay. Is something like 16 hours. Okay. Now I do tend to want to click on something else because sometimes AI can get a little out of sync with the world. But yes, about 16, so roughly 16 hours. And so 16 hours, that's about 3 hours away. So that's really tough to get. And then linear was also tough to get. But so we went down this list, and this is sort of the first one. So like I said, this is the brightest, next brightest. So we're coming down to this one, which is not the brightest one in the sky now, but it should be. This could be really, really exciting, or it could be, oh, it looks like an asteroid. There's the saying that comets are like cats. They have tails and they do exactly as they want.
Mm.
Yes, and so go ahead and Google that one. That's a fun one to look at. Okay, so typically when we're observing something like a comet or an asteroid, we need to watch because if our exposure time is too long, then the object will move by the time we finish the integration, and you'll get a blur. You'll get this motion blur. But we're going to track on the asteroid, so I don't care so much about that because it'll be the stars that are blurred. The telescope will stick on the asteroid, or on the comet, I mean.
On the comet.
Yes, thank you. And so let's just go for a nice, good, let's see what this is an integration exposure time calculator. So this is like when you've got your camera and you have different shutter speeds. It's the exact same thing, except for the shutter speeds could be, exposure time 2 seconds. Okay, so let's go with exposure time of, let's say, 30 seconds and see where that puts us, just out of curiosity. Okay,
Oh,
that's a little better. Go
okay.
ahead.
Can you explain SN, the signal to noise there? Because that's pretty important component.
Oh yeah, thank you. So the signal to noise is so it's literally just the signal divided by noise. How big is the signal? How big is the noise? So if we look at an image, let's go back to this image here. Let's look at this one. Just let us zoom in on one. Thank you. Site was sitting there going, oh, you want to see an image? Here, I've got all these. Okay, so if we look carefully, you can see there's a little bit of the black areas where there are no stars. There's a little bit of variation in there. That's the noise. So there's a little bit of variation in how each pixel reads. And how much that varies, well, if it were really big variations, it would be hard to see the comet. But the comet has enough light, it's bright enough that it can easily be seen in comparison to the just random variations that are in here. And so that's the signal, is how much light you're getting from the comet. And the noise is sort of how much bouncing around we have in here. That's sort of how to think about it. So that's the signal to noise. And a signal to noise of 400 is going to be nice and clear. The other thing that I want to see is the peak data number. How bright is the brightest pixel expected to be if this is how bright this object is? So magnitude is a measure of how bright the object is, and larger numbers are actually fainter objects. It's a little backwards. I think we discussed that last time. And so here's our peak data number. So 16,000, that's actually a very good range where I'd like that to be. So we'll go ahead and go with 30 seconds. Quickly, we'll check the green and the blue. Okay, it looks like those are a little more sensitive. Let's just go with 25 seconds on this. And did everyone pay attention? What do we need? Do we just need a blue filter?
No.
This is me trying to drag you in and make it a little more participation. I know you're muted, you can't talk, but you can wave a hand at me every now and then. Makes me feel like
Yeah.
I'm talking to people.
Well, JD, with we have just about 20 people. I can unmute everyone so they can um, chat with us if you'd like. Do you want to do that?
What do you think so? What do you, if you think if you want to do that, I'm more than happy to do that.
Let's try it.
Okay. Okay. Sounds good. Okay. So aloha, everyone.
Okay, so everyone
Everyone's
should be
muted
able
still.
to, but you can unmute yourselves now
Okay.
if
Yeah.
you'd like. No pressure.
So instrument configuration, and this way it'll be a little easier for you to ask questions, but feel free to ask questions in the chat or however you want. This
And we
is,
do have a question in the chat when you finish
oh,
this
yeah. Oh,
observation,
that would be great.
submitting this
Okay.
request.
All right. As soon as we're done with submitting this request, we'll do that. So this is the name of the object. Now remember, the sidereal, it just tracks the rotation of the Earth, but this object is also orbiting around the sun, and it's orbiting fast enough compared to its distance that we can see it moving across the sky. Okay, not with our unaided eye, but with a telescope, you start to see that. And so we want to track on the object. It also makes it easier to you don't have to look up the right ascension declination, which is the real reason I'm doing it. So we want to go non-sidereal, and this is a comet. So minor planet center, major planet, comet, or minor planet, or major planet, or comet. And this is a comet, so we probably want that. Back in the early days when they did this, we're doing this, I actually entered a comet as an asteroid, and I actually personally typed in all these orbital elements. And next thing I know, I get an email from one of the people there that said, JD, the eccentricity on this is too high. You've got to put it in as a comet. And so, because apparently they were having issues with it tracking well. Okay, so we've got red, green, blue. So red, green, blue filters. We've got the orbital elements, and we've got these constraints. Usually we leave alone. This is where it's visible. In the plot that we had for the last one, there was just a little bit, about an hour worth of time that we could see that coming. But this is now the for this object, and so might be from the Canary Islands, might be from Texas, or even Haleakala. Yay, we like Haleakala, or at least I do. And
I
then
do
back
too.
to Canary Islands. Okay, so this looks great. All right. And we're going ahead and submitting that. All right. So, okay, what was the question we had?
Okay, so let's go back to our first question. Um, so the first question is from Annalise. Thank you for being here. Thank you, everyone, for being here. And questions are welcome in the chat. And you want to ask it out loud, just raise your virtual hand and we'll do that too. So Annalise is, she's an astrophysics student in South Africa, and she's part of the Astronomical Society of South Africa. So always super excited to have her.
Oh, very cool.
Yes. So the question is access to the Las Cumbres Observatory network data and requests open, or are there restrictions to make use of this facility if one would like to request spectra, for example?
So requesting your own observations, you would have to do something like submit a proposal and be awarded some time. I know that since one of the telescopes is in South Africa, there's some way of getting time. I used to know the guy that worked for Las Cumbres down there, a guy named Adi, really nice
And
guy.
this is the Sutherland
Yeah,
Observatory, correct?
yeah, the Sutherland Observatory in South Africa. So you could actually get observations from it, but there's also, you can go on to the, some of the data does not have a proprietary period. In other words, the data is just open to the public, and so you can look around and find things like find observations that other people have taken. In particular, I know that I'm pretty sure that the observations taken by the kids at Wailuku Elementary. Yes, I'm giving them a shout out again. Yeah, we like
Yes.
Wailuku.
Yes, we
These
do.
are some students from the Big Island. Let's see here. Oh, let's see what Zane's looking at.
Are we just like looking at someone else's observations, JD? Is that what's happening right now?
Yes, this is a student over at Wailuku Elementary, and I haven't talked to him for this session, but I've talked to the teacher over there and asked, "Is it all right if we share it?" And he said, "Oh yeah, that'd be kind of cool." So this is like an elementary school student, maybe fourth grade, and so yeah, and so we could go in, and if we could figure out what was interesting about this, we could do some interesting things. But apparently that's a secret that maybe Zane is keeping to himself. So, oh, but here you go. You can see the noise level a little bit better in this image. Okay,
Yes.
so if this, you can see this star here because it's much brighter than this noise. So it's many times the noise level. All right. So yes,
JD,
there are observations you can get. Sorry, that's the short answer. Go ahead. Sorry.
oh, perfect. No, that's a great answer. And I love how detailed your responses are. And I apologize. There's, I think, a bit of a lag on my part. So I apologize.
No,
Um,
no.
I will follow up with you to see if we can get maybe a contact through LCO that Annalise can connect with about getting more access to Sutherland, because that
Yeah.
I know that could potentially be really, really helpful for her and other members of the Astronomical Society of South Africa.
Yeah.
Okay, so our next question is going back to um, looking at some of the info on the comet. Why does the eccentricity appear as greater than one? Oh, I love this question.
Yes. And so, well, an eccentricity between 0 and 1 is an ellipse, but greater than 1, well, let's
Mm,
see here.
that's interesting. I love it.
Yeah.
Can we get that orbital view for of the plane
Hmm.
of how things are orbiting? Because I love that visual. It really helps to um, bring home the what eccentricity is.
Yes, we can certainly do that. Okay. So this orbit, this eccentricity greater than 1, basically what it means is it's it indicates that the object is unbound. So it's on a hyperbolic course through the solar system. And so it's only going to pass through the inner solar system once. Um, and
Oh,
it's a long period comet. Whether or not it's really unbound, I'm I'm I don't really think that we are that certain because it was only slightly over 1, if I recall correctly. But yeah, that was a really good question. Sharp
yes.
eyes there. Bravo.
All
Okay.
right. Fantastic. Okay, next question. What does the color and structure of the cluster, so going back to globular clusters, one of my favorite
Hmm.
objects, what does the color and structure of the cluster reveal about the types of stars it contains? Yes, brilliant question. Y'all are on it.
Yes, this is great. So this is if we really want to go into it, start
Yes.
looking at color magnitude diagrams. Okay.
Ooh.
This is like how bright the object is in blue compared to green. And then up and down is the brightness in green. So up and down is like how bright is the star? Left and right is the color. And so if you plot, you look at all the stars and you take each star as 1 point. You measure the color and brightness of that star, and then you put a point for each star that you do that with on this diagram. You'll end up with something like this. Okay. And so down at the bottom, these are the faint stars. These are the faintest stars. And they tend to be kind of redder, quite a bit redder than most stars. So these are small red stars. These are a lot of the red dwarfs. And then this is where it turns off. This kind of indicates how old the stars are. And then this goes up into the asymptotic giant branch and then comes over here. These are your red giants. Actually, these are your red giants. These are bigger and brighter stars. And so uh, this is this is what you can learn about it. So you can kind of put a limit on the age. Once you get to a globular cluster, though, the ages are so old that it's you're only just saying, yeah, it's over 1 billion years. Maybe you don't have a lot of way to tell because these old stars, these small stars, evolve so slowly. But you can tell, what their age is, and individual stars. You can kind of get a little bit of an estimate of their size. So yeah, so great questions. I love this.
Yes, wonderful question. And I did put a link to this color magnitude diagram, also known as the Hertzsprung-Russell diagram or HR diagram. I put a link
Mhm.
to it there in the chat. Okay, so we
We have a
actually, let me,
green. Do we have another question?
oh, yeah, we do. But first, tell us about the green because green is exciting.
Yes, green means we have observations. So
Yes,
I
we have
this is
observations.
why we decided to do this, is because to me this is like magic, that now we have observations from
Oh,
South America of our target.
let's take a
They
look.
are not reduced though. Why are they not
Oh,
reduced? Okay.
uh-oh.
Well, let's view the color image. If it will do it. I don't know if it will do it.
And I will share this image. I'll share this with you all a little bit later with everyone who's in this session. So no worries. Wow, look at
Yes.
that. It's like
Okay, yeah.
unwrapping a celestial gift.
Oh yeah, unwrapping a celestial gift. That's good. Yeah, and here we're starting to see this is the globular cluster. I think this is just black and white. This is one of the three filters. So it's actually technically probably like blue and white or green and white. And that's our globular
Wow.
cluster.
Wow, that is absolutely incredible. That's beautiful. Can we zoom in on that a bit, JD? Or
There you
maybe
go.
not. Oh, that is stunning.
You
That
see, her
is stunning.
excitement about this is why I let her get away with these kinds of things, everyone.
Oh.
I just love your excitement, Jamaica.
Thank you. Thank you for indulging me. And I'm glad
Yes,
that the audience is also interested in
that is
seeing.
really, yeah,
That's
that
gorgeous.
it really is a beautiful globular cluster.
It really
Yeah,
is. Oh, wow.
yeah.
Um, can we leave that on the screen while we answer the next few questions? Just to, is
Sure. Let
that
me do
okay?
this.
Okay.
I'm going to put it over here, and I'm just going to put this like that.
Ah,
That way, if I
wow.
put something in front of it, then we'll still kind of know that it's back there.
I
There
love
we
it.
go.
That's
Okay, what was the
incredible.
next question?
Okay, next question. Let me, okay, so actually we have a follow-up question to the one that I just asked. And that follow-up question is does it exhibit signs of multiple stellar populations? And how is this reflected in its appearance compared to other clusters like Omega Centauri? Yes.
Wow, getting the real deep questions.
I love it.
Um, I don't know if this cluster shows evidence of multiple epochs of star formation. So for those who are a little less well versed, um, uh, not all of the stars. It's possible to have several different periods where stars are forming, and the question, and if I'm recalling the question correctly, the question was whether or not we had uh, different epochs. Yeah, multiple
Mm-hmm.
stellar populations.
Mm-hmm.
Okay, so in a cluster, let's think about how you would get different populations. So there's age, that's one population. And there's also sort of metallicity. You could also say that's a different stellar population. They're very similar, but there's some distinctions when you start having different metallicity. So metallicity is how much stuff that is not hydrogen and helium is in the star. Usually, and think of that other stuff as like seasoning. How heavily seasoned is your are your potatoes or whatever.
Mhm.
Okay. And so, well, in order for there to be more of these heavier elements in a group of the stars, probably what needed to happen is would have to be two periods where the stars were forming, because you'd form the first stars out of the gas and whatever composition the gas in between the stars was at that time. That's what those stars would be made of. And then you have an explosion, you put some iron, some sulfur, some oxygen, all this good stuff into that interstellar gas, and then you form some more stars. That's so so I think really different stellar populations probably need multiple periods of star formation. I don't know if there's any evidence that this cluster has that, but I might not be aware of it because I have not done a lot of research on this. Um, let's look and see if there's anything. I'm skimming through this article.
Hmm.
Yeah, okay. So the brightest star is, well, it's surprising that that's it, but I guess it's just a star is visible in, that's very interesting. Yeah.
Mhm.
Oh, you're right. So 47 Tucan contains at least two populations of stars of different ages or metallicities.
Oh,
Okay, so
wow.
yeah. Okay, well, hey, thank you. That I've learned something a little bit here.
Me too.
Oh, yes. Mixed
Definitely.
populations in globular clusters. Okay,
Can you
47
click on that
toucan.
paper link for us, JD?
Yeah, we could do that.
And this is in the archive, which is a great place to find papers on a whole range of topics, but astronomy in particular is it's a place that I peruse all the time. So you can find so much information here. Yes. Can you drop a link to that paper in the chat first, JD?
Yeah, sure. The
Thank you so
paper
much.
is right here. I can find the chat again. Okay.
So there are
Okay, here's your link.
two populations of stars that make up 47 Tucane.
Yeah,
Wow.
very cool.
Yes. And Annalise was just saying how, of course, in South Africa, they can actually see this gorgeous cluster.
Yes. Yeah, and I see someone saying we can see Omega Centauri here. Definitely my favorite. Oh, is that
Oh, that's
you?
me. That was
Okay,
me.
yes.
I
Okay.
love Omega Centauri.
Yeah,
Okay,
Omega
back.
Centauri is really great. And
It
I
really
really
is.
like this one too. I'm going to put this over the side a little bit so we can see it when I do other things a little bit
All
better.
right. Awesome. Okay, let me get back to questions here. Oh, we only have 15 minutes left in this session. Where does the time go to?
I don't know. It's just, hey, we've got comets.
Oh, okay. So, can I ask this question and then we get to look at this comment?
Okay, go ahead and ask the question and we'll look at the comet at the same time.
I love it.
I'll get this up.
Yes,
Yeah.
multitasking. Okay, so um, do how many different? And this is great. We're back on comets. So the question is, how many different variety of comets are there, and how do you differentiate between them based on live observations, if possible?
Um, I can think of two types of comet right off. There are probably, actually, no, three. So there are long period comets. Those are ones that most likely came from the Oort cloud. So imagine this globular cluster, but instead of stars, each one of these was a comet-like object. And somewhere tiny deep inside the middle here is our solar system. All these chunks of ice are orbiting the sun in every random direction. And when those chunks of ice get pulled into the inner solar system, they're close enough to the sun that the ice starts turning into a gas and we see a comet. And so those are, that's the long period comets. And then just outside the orbit of Neptune, there is a belt of icebergs again, kind of like the asteroid belt, only it's comets. And when those get pulled in into the inner solar system, they again start acting like comets, showing off like comets. And so those are the short period comets. There's also Manx comets, which are comets that don't have tails. I don't know. So
Oh,
yeah, I don't know quite how that works. Um,
I thought
I
a tail was one of the characteristics of a comet.
yeah, I know. But apparently they started seeing some objects, and it's like, well, that's a comet. You can see the coma, but it's
Mhm.
there's no tail or something. I remember, I
Huh.
think it was Karen Meach that may have been the one that named those after Manx cats, which have no tails. Um, and then for a while there, a student and I, the student that I was working with, and I, we had helped discover a comet that was in among the Trojan asteroids, which are objects they kind of orbit in front of and after Jupiter in its orbit. And we thought that the comet was a member of the Trojans. And so for a while there, we thought we had discovered the world's first, or the first discovered Trojan comet. And so, but that was not the case. So,
Ah.
all
Oh,
right.
that's really really fun
Yeah.
though, just to potentially have discovered something new. So,
Mm-hmm.
is the comet right there in the center, JD? Is that what we're
Mm-hmm.
seeing? Oh,
Yes. So this is the comet, and it's a lot fainter than expected. I'm pretty sure because that's nowhere near as bright as I would have expected it. It could be that that's the blue image. Let's see if, um,
yeah, I was expecting that to be a bit brighter as well.
yeah, so this is the red image. Okay, like I said, comets are like cats. They have tails, except for Manx comets and Manx cats. And and comets do exactly as they like. Just like cats, they do exactly what they like. So there's the comet. It's very faint. Yeah,
Hmm,
it's still kind of
okay.
cool.
Oh, it's
All
definitely
right.
cool. Definitely cool. And while we're have this comet image up that
Oh,
is amazing that we were able to get both of those observations back during this session. Wow.
mm-hmm.
Um, we have a question going back to that eccentricity being greater than one. So here's a follow up to that. So if the eccentricity is greater than one, does that mean, oh, let me go back to that. Does that mean that it will only pass the sun once? And well, that does mean that it
Right.
will only pass the sun once. But why is that?
Because it's got enough energy that it's an unbound orbit. So basically, you can have a bound orbit in which it's elliptical like this, but if it's moving too fast to begin with, imagine at a very, very great distance, it's moving pretty quick towards the sun, and then when it comes into the inner solar system, it whips around the
Ooh.
solar system and then just goes off, and it doesn't, and then it never, the sun is not able to slow it down. There's just not enough gravity. And so when the eccentricity is greater than 1, it's an unbound orbit, it's a hyperbolic orbit, and it goes off. It goes through the inner solar system once and then off forever.
Oh, bye-bye. Great
Yes.
questions. Great questions. Thank you, JD.
Mm-hmm.
Okay, so let me just make sure I haven't missed any. All right, yes. So we have another question, and thank you for the links to some beautiful images, Annalise. Wonderful. Check those out
Yes.
on Hubble.
Yep.
Okay,
I was
so
noticing those.
I have a question, again, talking about the comet. Has it already passed its perihelion? Uh, Tell us what perihelion is first, JD, just as a refresher, and then has it passed its perihelion?
I don't know. So perihelion, para is close, helion is sun. So perihelion is the point at which it is closest to the sun. Um, let's take a look. Let's take a look at its orbit, and hopefully, okay, so it was discovered by Atlas, the Atlas project in Chile. That's great.
Mm.
Um, oh, they don't give us perihelion date. Uh, Looks like, yes, it has passed perihelion.
Ah, okay. What? Mm. So let me drop a link here to the Minor Planet Center, which is just a wealth of information on comets and asteroids, and just bodies in the solar system in general.
Mm-hmm.
So, so okay, so it's already past its perihelion. Um,
Yeah, so this is on the way out of the solar system, probably to never be seen again,
ooh, well, glad we
or
got some images.
certainly not in our lifetimes.
There you go. Okay, there's that link to the Minor Planet Center. Oh, JD, you beat me.
Oh, yeah.
Great.
Okay.
All right. So we have 5 minutes left, JD. Um,
Oh my goodness. Yeah.
the time is flying almost as fast as this comet is.
Uh-huh. Yeah, it really has. Do we want to really quickly check up on the list of things that I've been watching that I might have discovered, or at least part of them?
Let's do that. Let's do that. And while you're transitioning to show us that, I'd like to read this comment that just came in. Thank you so much. Thank you all for the engaging questions and comments that you've been you've been sharing. Yes. So let's see. Question. So it says, I joined this session just out of curiosity, but it's been so fascinating. The process of
Oh,
observing objects, right? JD, this is all you. The process of observing objects, the various factors related to it, like brightness, ascension, is really interesting. The interesting information about comets, too. And different outliers, like ones that don't have tails, which is fascinating. Such an engaging session. So thank you so much for that comment. I don't want to mispronounce your name, so
yes.
um, but thank you. Wonderful.
Yeah, thank you very much.
Yes, and yes, you will all get an image of the cluster and of the comments. Afterwards, JD will share those with me. I'll send a follow-up email with the survey and a link to these images.
Okay.
I think Hinal, do you have a question, Hinal? You've unmuted.
Hello.
Hello, Hinal, did you have a question?
Oh. Okay.
Oh, okay. No worries. No worries. Okay.
Okay.
3 minutes, JD. Follow-ups to some potential discoveries that you made, asteroid discoveries.
Yes, so I'm just going down the list. This one is not a match. This one's not a match, but come down here. This one here is a match. It is an object that was discovered in 2024, so this year. And so I'm going to, no, that's not it. Go ahead and search on this. Let's see if this is possibly Ceratololo on August 10th.
Ooh.
So
that could be
Ceratololo, yeah, so August 10th. So that looks like this is probably something I might have discovered. Very cool. Let's take a look at the orbit, shall we?
Yes, let's. Congratulations.
Right. Yay. Well, it's not certain yet, but I will take the congratulations. And that one's pretty far out of, I like it when they stick up out of the plane of the orbit like this, or plane of the ecliptic like this, because it makes them a little more unique or special to me. This is a main belt. I think this said it was main belt. Yeah, main belt. So there's like a million of them, but anyway, so this is possibly a new discovery by me, and so I'm really excited about that.
I'm so glad we could all be here as you found that out and that you shared it with us live.
Yeah, well, I'm really glad to have people here to share that with. Thank you for joining us and sharing with that.
Absolutely, absolutely. And perhaps in our next session with you, which we don't have a session with you in December, you're going to take a well-deserved break, but perhaps at the beginning of the year in January or February, we'll have our next session with you, and maybe you will have gotten some confirmation as to whether or not you did, in fact, were the first to look at this asteroid.
Yeah, it seems very likely, but beyond that, I think it would take quite some time. Well, wait a minute. Actually, wait a minute. So we can confirm here. Let's see.
Oh.
Yeah, this is, yeah, this one is my observation. So yes, and then Pan-STARRS. Next observation was Pan-STARRS like a month later. I got ahead of them. I beat them on one. Yay! All it took was a hurricane. They were off sky for several days due to a hurricane, and so that apparently, in order for me to find an asteroid, I need a hurricane to help me out. I'll take it.
Gosh. We're getting lots of congratulations here in the chat to you.
Well, thank you all.
Yes, for this potential discovery, and much appreciation here being shared for such an informative and engaging session. Yes, thank you all. You all made it really very special by your presence, your questions, your comments, your excitement to be here and share this experience with us, shadowing JD Armstrong as he's using Las Cumbres Observatory's network of robotic telescopes to schedule observations actually getting to observations in within the session. We've never done that before. They've always come after. So this is special. This is special just for you all. Thank you all so much. Great comments, as I said, and this really makes it engaging. It really does, and it makes us really excited to keep doing this, right? JD, will we see you back with us next year?
Of course, I would be more than happy to. And can we give you a round of applause too, Jamaica? You've been so wonderful hosting these. And Jamaica, let's give the audience a round of applause as well, because we really appreciate you. So thank you
Yes,
very much, everyone, for coming.
thank you all so very much. I will get these images filed from JD and share them with you in the follow-up survey. And JD, we wouldn't be able to do this without you. So a huge round of applause for you and for allowing us to shadow you on this cosmic journey.
All right. Aloha and thank you all.
Aloha.